Hey guys, and welcome back. Today we're going to be learning how to solve equations when you see variables on both sides of the equal sign. Our learning target today again is going to be to solve linear equations in one variable. We actually did this yesterday when we brushed up on two-step equations. Our success criteria for today though is going to be to apply the addition-subtraction property of equality. We did that yesterday. To apply the multiplication and division property of equality. We also did that yesterday. And this time we're also going to create an equivalent expression by clearing the denominator using the distributive property or combining like terms. We're actually going to be saving the distributive property for the next lesson when we practice these problems a little more, just because I feel like I'm throwing a lot of examples at you at once in this one. But once you get the hang of it, it's really just the same thing as we've been going over the past couple days. So our key idea here, I have a little snippet here that says when you write an equation, you set two expressions equal to each other. So what that means is this side of the equation is an expression, and so is this side of the equation. Okay, alone, if you were to just write 2x plus 6 and then negative 3x plus 1, I just wrote two expressions. But once you set them equal to each other, it becomes an equation. When you solve an equation, you find the value of the variable that makes the two expressions equal. Sometimes both expressions contain a variable in those terms. So think about it this way. Let's say I had a balance beam, okay, kind of like how we were talking about yesterday. And on that balance beam, there are boxes that we don't know what's inside the boxes. Okay, so if I were to represent the left side on the balance beam, I would see two boxes to which I don't know what is inside. Okay, and then I would see 6 unit pieces. Okay, on the right side, I would see, it says negative 3 boxes, so that means it's actually 3 boxes light. So negative box, okay, we'd have to take away a box, take away a box, take away a box, and then there'd be one piece left over on that side. So in order to maintain balance here, you would want to take all of these negative boxes and move them over to the other side. You want to combine them together with the other boxes. But in order to do that, you have to do the opposite. So you'd end up adding 3 boxes to this side, because then the negative boxes and the positive boxes would cancel out. And the balance beam would still be balanced if over here you had those positive boxes again. Okay, so it'd still be balanced if you just added the opposite of what is there. So now this expression becomes 5x, plus 6 is equal to 1. And just by going for the x's first and bringing one of the two to the opposite side, you create a two-step equation, which we practiced yesterday. So let's give this a try. We're going to actually look at 2 different ways that we could solve a problem like this. And if you notice, this is the same equation that we had in our key concept slide over here. It says to solve this kind of equation, bring all of the variable terms to the same side of the equation. Now, the way that I decided to do it when I gave you my balance beam example was the bottom one right here. Okay, I decided to take the 3x and add it to both sides so that all of the x's ended up on the left side of the equation. There they are, the 5x's. Okay, you could also do it the other way, where instead of adding 3x, like I did over here, I added 3x and added 3x to both sides of the equation. You could instead subtract 2x from both sides of the equation, getting these two x's to cancel, and they end up going over to the other side of the equation, making negative 5x. Okay, now if you do either one of these methods, you still get to a two-step problem. They look very slightly different, but if you solve them correctly, you should come out to the same answer. So in this one, the top one, I would subtract 1 from both sides to get rid of the 1 there, because again, my variable is on the right side of the equation. We don't want to move the variable once they're together. we're going to kick out all of the other numbers. So now I have 5 is equal to negative 5x, and we would divide by negative 5. Positive 5 divided by negative 5 is equal to negative 1. But you can do the same thing with the method that I started with on the last slide, which if we have 5x plus 6 equals 1, we now, since x is on the left side in this example, we would then subtract 6 first, because again, now x is on the left side, so we got to get rid of all of the other numbers that are on the left side of the equation. We'd have 5x is equal to 1 minus 6 is negative 5, end up dividing by 5 again, and you still get x is equal to negative 1. So there are actually many ways you can solve these multiple step problems. I would just say the best way to go about this is to combine the variables first. We're going to do this by using inverse operations. Okay, in order to get a term to end up on the other side of an equation, you have to do the opposite. Okay, it's got to be the opposite operation in order to get it to move. You can't just take this negative 3x and just put it over there and write it. Okay, you have to do the opposite to get rid of it from one side, and then it'll end up on the other. So let's try this in our first example. Okay, so my tip was to go over the variables first. Another easy tip is to try to move the variable that is the smallest. So if I look at my two variables here, I have 6a and I have negative 1a. Okay, now negative 1a is less than 6a. So it's easier if you actually get rid of the negative 1a first. Okay, because then you don't have as many negatives when you're trying to solve. So what I'm going to do is, since it's starting off as negative 1a, I'm going to add 1a to each side. I need to scoot this piece over. So I've got 6a plus 14. I'm going to leave some space. Again, if you need to, draw your line. Minus 7 minus a. If I add a, that means negative a and positive a will become 0. But I need, whatever I do to that one side, I have to do to the other. Now, combine like terms. Okay, so I see 6a's and I see positive 1a. Those together would be 7a. Drop down everything else. That plus 14, drop down your equal sign, and you have a negative 7 left over there. Now we have a two-step problem. We practiced this yesterday. Okay, 2 steps. You're going to look for addition or subtraction first, then multiplication or division. So I see the first thing that's got to go, that is by a, is 14. Again, you only want to move the numbers that are on the side the variable is on. So we are going to subtract 14 in order to get rid of the positive 14 on that side. So 7a plus 14 minus 14 will get that to become 0. But whatever we do to one side, again, we have to do to the other, so we have to subtract 14 from both sides. So we have 7a is equal to, again, make sure you're using your number line, start your i's at negative 7, and then subtract 14 by going left 14 units. That means you're going to get negative 21. Then the last step, divide by 7. Negative divided by positive is negative, and then 21 divided by 7 is 3. And there's your final answer. So let's have you give this a try in your first U-try. Again, go for those variables first. All right, let's try another one. And you should also be on the lookout if you have to combine any like terms right away before you start solving. You should always make sure both sides of the equation is simple before you start moving around. So if you look back at the first example, you notice how if you were to just focus on the left side of the equation, there's no terms that you can combine together, okay, because this term has an a attached to it and this one does not, okay? It's just a 14. It's not a 14a. So they are not like terms. You can't put them together. Same thing with the right side, okay? One's just a -7, doesn't have an a attached to it. One is an a. Okay, you can't combine those things together because they're not like. Like terms have the same variable in the same exponent, in which all of our exponents, since we're dealing with linear equations in one variables, all of them are going to be 1, or they're not going to have any exponents written. Okay, same thing with your last u-try. Both the left and the right sides were completely simple, so that's when we started moving the variables around to get them together on one side. Okay, well here I see, let's put our wall up. Okay, I see on the left side, if we just focus on the left side and ignore the right side, I see some like terms that we should be putting together, b and b, right? Technically, we have 1b here, and we have 1b here. Well, 1b plus 1b is 2b. Drop down that plus 18, and now let's look at the right side. Now, the right side only has one term. So it's not like we can combine that together with anything else. There's nothing else to combine it with. So we just have equals 4b. Okay, so now we can actually start getting the variables together. Okay, so I see 2b. Actually, let me zoom in again. Sorry. Okay, I see 2b over here. I see 4b over here. I want to get those together. Now, my recommendation on this one is because the 4b is all alone, there's no constant with it, I would not subtract that. I would not subtract 4b, because if you did that, you would leave 0 on the right side, and then you still would have 2 steps or 3 steps you would have to do in order to solve. So if that's the only term you see, don't grab that one. Grab the other one. I don't even care if it's smaller. In this situation, the one that we're going to move is the smaller term, but even if it were larger, don't move the term that's all alone. So rewrite, only scoot it over, 2b plus 18. Drop your equal sign down, drop down your 4b, and you want to subtract 2b from each side. So now 2b's minus 2b's, that's 0b's, and you're just left with 18. And now you can combine your b's together on the right side. 4b minus 2b is 2b. Now we have a one-step equation. In order to get b alone, you got to get rid of that 2. 2 is multiplying b, so divide it off. 18 divided by 2 is 9. So b is equal to 9. Let's have you give this a try in your second u-try. Again, focus on one side at a time. Combine any like terms first on each side of the equation, then start trying to move your variables to one side, then use inverse operations to solve. So I got a couple more examples for you here that is really practicing the same skill we just learned, but now you might have fractions sitting next to the variables. And what I want to remind you guys of is a term that you may have learned, or you should have learned in 7th grade, which is the LCD. This is the least common denominator. Okay. The way that I usually come up with the least common denominator, it may not even be the least common, it'll just be a common denominator, is I will multiply the two denominators together, if they're different. Okay, but notice how in my two examples here, part A, the denominators are the same, okay, they're both 2, whereas in B, the denominators are 3 and 9. Okay, so we'll talk about what we can do in order to find the least common denominator or even just a common denominator. Okay, so let's do the first one. And again, common just means the same. So because these two denominators are already the same, your LCM is 2. Okay, so denominator of 2, denominator of 2, you have an LCM of 2. That is basically telling you what you need to multiply everything by in order to get rid of the fractions. So what you can do is just on the left side, multiply the entire expression, everything, not just the fractional term, but the entire expression. Notice how I put the parenthesis on the farthest to the left and then the closest to the equal sign. I'm going to multiply that entire left side by 2. I'm also going to multiply the entire right side by 2 because, again, my golden rule of algebra is whatever I do to one side, I must do to the other side. Now, we practiced the distributive property yesterday. So take that 2, multiply it into both the terms on the left side. 2 times negative 1/2, or half of 2, is 1. But a positive times a negative is negative. So this is negative 1c. And then 2 times negative 5 is equal to negative 10. Drop down your equal sign if you need. Put that line down so it doesn't go anywhere. And then do the same thing for half c times 2. Well, a half times 2, or half of 2, is 1. So we again have 1c. And now we're back to the same process that we were going through before, where I see a variable on both sides of the equation. And I also see, okay, so the last couple times I've been saying you should pull the smaller of the two. You should move the smaller of the two. Well, this one is the smaller of the two. Okay, so I do want to use that one, but if this one were the smaller of the two, I still probably wouldn't touch that one because it's the only one, it's the only term on the right side. So you don't want to move something that's the only thing there. Okay, so let's move the negative c over to the other side by doing the opposite operation. So scoot everything over, negative c minus 10 equals c. And since it's a negative c, we want to do the opposite, so we want to have a positive c on both sides. Because then negative c and positive c becomes 0. That's what we wanted. We wanted to move the c to the other side. We just have negative 10 now on the left side. C plus c is 2c. Now we just divide that by 2 to get the c all by itself. And you get that c is equal to negative 5. So even though you had fractions in the original equation, sometimes the answer might turn out to be an integer anyway. Okay, we might still get fraction answers. Don't be afraid if your answer is a fraction. But just remember, and I'm going to write this as a note, and I think you should write it too. Okay, if problem, oops, sorry, I keep moving the screen, starts with fraction, with fractions, answers should be integers or fractions. Okay, I don't want to see people writing decimal answers when the original problem started off with fractions. We need to make sure we are practicing both fraction and decimal versions of numbers. Okay, so on this one, the LCM here, usually in order to find the LCM or just a CM or a common multiple, you can just multiply the two denominators together. 3 times 9 is 27. Okay, but that's a really large number. You could also try to come up with the LCM, which is the least common sorry, I keep saying M, it's supposed to be LCD, denominator, not multiple. But the least common denominator would be the smallest denominator you can get from multiplying it. So 3 can actually be multiplied by 3 to get 9. So the least common denominator would be 9. Okay, that way when we multiply everything by 9, then both of those denominators will go away. Okay, so we're going to use the number 9, since 3 can become a 9, as what we multiply both sides by. So again, put your parentheses around both the entire sides, the left and right. And now we're going to use our distributive property to multiply it in. Now you can use a calculator if you want to figure out what 9 times 2/3 is, but I'll make a little side note. 9, or 9 over 1, times 2/3. Whenever you multiply fractions, you're basically just multiplying the numerators and multiplying the denominators. 9 times 2 is 18. 1 times 3 is 3. 18 divided by 3 is 6. So 9 times 2/3 is really just 6. So we have 6v minus 9 times 4, which is 36. Make sure you drop down your equal sign. You can put the wall in if you want so the equal sign doesn't move. And then now we need to do the distributive property once again on the right side. Okay, the number is going to be negative because I see a negative here. Negative times a positive 9 is going to be a negative. And again, if you need to, you can do some fractional math here. 9 over 1 times, sorry, what was that fraction? 2/9. 2/9. Again, we just multiply straight across. It's only when we add fractions or subtract fractions that you need a common denominator. 9 times 2 is 18. 9 times 1 is 9. 18 divided by 9 is 2. So we have negative 2v plus, oops, sorry, I was almost about to write 4, which is a common error. You also need to multiply that 4 by 9 as well. So plus 36. And now we're back to one of the problems that we've been solving throughout this entire lesson. So I need to first get my variables together. Here are my two variables. The smaller of the two is the negative 2. So I'm going to move that one by scooting everything on the left side over. 6v minus 36 is equal to negative 2v plus 36. And I'm going to insert, since it starts as a negative 2, I'm going to add 2v to each side. So that will move this 2v because they cancel. Negative 2v plus 2v is 0. And then you're left with 36 on the right side. Combine your like terms together, 6v and 2v, that's 8 total v. And then minus 36. Now we're back to that two-step problem that we know how to solve. Get rid of addition or subtraction first, then multiplication or division. So again, scoot everything over. 8v minus 36 is equal to 36. And we're going to need to get v all by itself. So that means we got to get rid of that 36. It's negative, so we got to add it to both sides. Okay, negative 36 and positive 36 go away. We're left with 8v is equal to 36 plus 36 is 72. Last and final step, divide that 8 off because the 8 is multiplying the v. And we get v is equal to 9. Okay, so two different examples that I gave you here on fractional type problems. And really, the easiest way to go about this, first step, clear out those fractions and then solve like we'd been practicing in example 1 and 2. Let's have you guys give this a shot in your third U try. All right, I've got just one last example for you guys for today, and we'll continue going over problems like this in tomorrow's lesson, but it's really the same type of thing as what we've been doing, only it involves decimals. And decimals you treat just like regular integer numbers and use your calculator just to make sure you're getting those decimal operations correct. So I don't see anything on the left side that needs to be simplified. Sorry, accidentally got rid of the numbers there. Okay, I don't see anything on the left side. Okay, we can't combine 2d and 9.7 together. Those are not like terms. I don't see anything on the right side that we need to simplify. Can't put anything together. D and 17, again, not like terms. Okay, so I'm going to draw my wall. And I'm going to identify the variables on both sides. I see 2d and I see negative d. Now, negative 1d is the smaller of the two, so I'm going to move that one by using inverse operations. So again, scoot the left side over, 2d plus 9.7. Drop your equal sign. I'm basically just copying down the problem right underneath it. And then I'm going to put my inverse operation, since on the right side it's negative 1d. The opposite of that is going to be positive 1d. So I'm going to add 1d to both sides, combine my like terms. Okay, so negative d and positive d, they make 0. But my like terms over here, d and 2d, that's 1d plus another 2d's, that's together 3d. Drop down the plus 9.7 and drop down your negative 17. Don't forget that negative. Okay, that negative is attached to the number. Okay, any symbol to the left of the number is glued to it. You can't get rid of it. So now we have, again, a two-step problem. Okay, d is now over here on the left side of the equation. And again, like my analogy, party time's over. It wants to get rid of all the numbers that are on its side of the wall, so the 3 and the 9.7. Look for addition or subtraction first, so we got to get rid of that 9.7. Scoot everything over. And since 9.7 is positive, we want to subtract it from both sides to get it to become 0. So positive 9.7 and negative 9.7 get canceled out or become 0. And we're left with 3d is equal to, and this is where I would go to my calculator to type in negative 17 minus 9.7. Okay, so let's see, there's negative 17 minus 9.7 equals negative 26.7. And now I just have that one more step to go. The 3 is multiplying the d, so I need to divide by 3. And now I have that d is equal to, again, I would go to your calculator. All right, so I already actually have negative 26.7 in my calculator, so I'm just going to hit divide by 3 equals negative 8.9. And that would be my answer. And again, it's acceptable that my answer is a decimal because the original equation started with numbers in decimal form. Okay, on the last example, the coefficients to certain variables were starting as fractions, so I wanted you guys to leave your answers as fractions. But if you see decimals, then you can leave your answers as decimals. Let's have you guys give this a try in your fourth and final U-Try. I got one last closing check question for you. See if you can do this on your own. It looks a little bit longer, but it's still the same skills that we've been practicing throughout the entire lesson. Just take it step by step like we did in all the different problems. Give it a try. All right, that basically finishes up our lesson for today. And actually, we did do all of these success criteria in all 3 examples. Okay, four examples. We exercised our inverse operations. Okay, that's the addition and subtraction property of equality. We use the inverses. Same thing with the multiplication or division properties. We used inverses of each other to solve. We also cleared fractions. Okay, clearing those denominators out. And we even used the distributive property in order to get rid of those fractions as well. Okay, so go ahead and start your Google form. Make sure you go back to any sections on this video that you may not have been clear on. Ask any questions, get the help you need, and go ahead and start your homework.